Alright, let's look at number 7 on this test. The number of rooftops with solar panel installations in 5 cities is shown in the graph above. If the total number of installations is 27,500, what is an appropriate label for the vertical axis of the graph? So essentially, what this question is asking is, if you were to add up every single number here, 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 each of these represent a different city. If you were to add all those up, you should get 27,500. So now the question is, what does this 9 represent? Does it represent 9, 900, 9,000, or 90,000? So that's what they want you to find. They want to figure out what is the appropriate label for this axis. So let's just continue with that train of thought. Let's say it is just 9. Let's say this axis is in tens. That would mean city A had 9 installations, city B had 5, city C had 6, D had 4, and E had somehow 3.5. They didn't finish the last one. So ideally, if we were to add up 9 plus 5 plus 6 plus 4 plus 3.5, we should get 27,500. No, that's not right. Looks like A can't be right. Same thing for 900. Same thing for hundreds. 900 plus 500, 600, 400, 3.5. So that would be 3,500. This would actually, 3,500, 350. 350. Again, if we were to add up all these numbers, we wouldn't get 27,500. We actually get 2,750. We'll fall short once again. And C is just an overkill because it says in tens of thousands. That would make this first measurement 90,000, which is already above 27,500. If we're to make this in the thousands, so where it's 9,000 plus 5,000 plus so on and so forth, we would get approximately 27,500. Answer choice of C. Let's look at number 8 here. For what value of n is absolute value of n minus 1 plus 1 equal to 0? So they just want you to solve for n here. Real quick, let's make sure what we know what absolute value is. Absolute value is the amount of places it is from 0. So absolute value of 5 would be just 5. Absolute value of negative 5 would be just 5. You may have learned it. Absolute value as it turns any negative number into positive. So I'm going to do an example here before I do this actual question, and it'll make sense in a bit. In order to solve for x in this case, just like we were to solve for n, I want to isolate the absolute value first. So get everything that is not inside the absolute value on the other side of the equation. In this case, this negative 1 is the only thing stopping us, so I'm going to add 1 to both sides. So absolute value of 2x minus 1 equals 5. Once there is nothing else being added or subtracted or multiplied or dividing my absolute value, then if you're not sure if you remember this, you can split up the absolute value and you can say this is 2x minus 1 equals 5, and also 2x minus 1 equals negative 5. So now let's solve for x in this case. 2x, so add 1. That equals 6. And x would equal 3. Same thing here. 2x equals, that'd be negative 4. Go by 2, go by 2. X equals negative 2. So what does that tell us? That tells us if we're to plug in x equals 3 or x equals negative 2, plug it into this absolute value and subtract 1. In the end, we'll get 4. Let's try it out real quick. But instead, we'll use this equation just to make it a little more simpler. So we'll do absolute value of 2 times 3 minus 1. That equals, well, this is, actually, I'll do it down here. Absolute value of 6 minus 1. And that equals absolute value of 5, which equals 5. So this looks like x minus 3 works. Let's try it with this other case. x equals negative 2. So, again, plug it into this equation. So instead of saying x, I will now say negative 2 and minus 1. And ideally, this should be negative 5. Sorry, this should be positive 5. So that's negative 4 minus 1. That gives you an absolute value of negative 5. And again, this equals positive 5. One more time. Whenever you plug in a number to your absolute value, it will always come out positive. So now let's address our question. All I've done right now is just rewrite this equation. For what value of n is n minus 1 plus 1 equal to 0? So again, they just want us to solve for n. So just like we did before, in that other example, let's isolate the absolute value. So get everything that is not inside the absolute value on the other side of the equation. So we can't affect this n minus 1 just yet. We have to subtract 1 first. So subtract 1. Absolute value of n minus 1 equals negative 1. And this is where I say we're done. Let's look at what we have here. Absolute value of n minus 1 equals negative 1. Is that possible? Can we plug in a number for n such that when we subtract 1 and take the absolute value of it, we get a negative number? That is not possible. Whatever you do to the inside of absolute value, it should come out as a positive number in the end. In this case, in this equation, we're getting a negative number. So the answer to this one is D. There is no such value of n. And even if there was, even if you decide to continue on with this and like, oh, let's split it up, you'll end up getting n minus 1 equals negative 1, and n minus 1 equals, what is that, positive 1? And if you were to solve for n in this case, you'll end up getting 0 and 2, which actually is answer choices A and C, so you'll be left stuck thinking, what did I do wrong? Since whenever you plug in a number and you take the absolute value, you should always get a positive value. Since we're getting a negative value here, that means there is no such value of n. This is impossible. Let's take a number 9 on this test. Notice 9 and 10 refer to both of the following information. They give you an equation, A equals 1052 plus 1.08 t. So it says the speed of a sound wave in air depends on the air temperature. The formula above shows the relationship between A, which is the speed of a sound wave in feet per second, and T, the air temperature, in degrees Fahrenheit. So number 9 says, which of the following expresses the air temperature in terms of the speed of a sound wave? So given this equation here, A equals 1052 plus 1.08 t. All they want you to do is just express this in terms of air temperature. In terms of a sound wave. Basically, all you do is just solve for t. So isolate t, get t by itself. I'll subtract 1052 from both sides, and I'll move this over. So 1.08 t equals a minus, that's an a and a 9. I apologize for that. My video crashed. But where I left off is just after subtracting 1052 from both sides, I will now isolate t, get t by itself. Therefore, I would divide both sides by 1.08, which would give me t equals a minus 1052 divided by 1.08, or answer choice of A. Going off of question 9, let's look at question 10 now. At which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? So remember that in our original question, it said that T was the air temperature and A is denoting the speed of a sound wave. So, given our equation from last time, let's just plug in 1,000 feet per second for our speed of a sound wave. So T equals 1,000 minus 1052 divided by 1.08. We'll get negative 52 over 1.08. And that will give us an answer choice of B. It'll be 48 point something, but it's closest to 48. We don't need to round up. Let's look at number 11 on this test now. Which of the following numbers is not a solution of the inequality 3x minus 5 is greater than or equal to 4x minus 3? So they just want you just to solve for x here. Alright, so let's do that real quick. I will now, let me add 3 to both sides real quick. So we have 3x minus 2 is greater than or equal to 4x. And I'll subtract 3x from this side, just so I don't have to divide by negative. That is a greater than or equal to sign. Let me rewrite that. So we have now, I apologize. A solution for this is any value of x less than or equal to negative 2. So which of the following numbers is not a solution to this inequality? Any number where x is not less than or equal to negative 2. So any number greater than this. In this case, a, negative 1 would work. But what does this mean? X is less than or equal to negative 2. Sure, we solved for x. Sure, we did everything. But what does that mean? That means any single x value that is less than or equal to negative 2, it works. It makes sense. So let's do that real quick. A number that's less than or equal to negative 2, let's try negative 4. X equals negative 4. Ideally, if I was to plug in negative 4 to this part here, ideally, once I work all this out, this side of the expression should be greater than or equal to this side of the expression. So let's try it real quick. 3 times negative 4 is negative 12, and then minus 5. 4 times negative 4 is negative 16, minus 3. And then negative 12 minus 5 is negative 17. And then negative 16 minus 3 is negative 19. And this makes sense. Negative 17, it is greater than negative 19. So what happens if we were to plug in, let's say x equals 1. And let me make some space here real quick. And again, let's go off that question. What happens if we plug in x equals 1? So just based off of this, 1 is clearly greater than negative 2. Ideally, if we were to plug in 1, this shouldn't work. It shouldn't make sense. Well, let's test it out. 3, and instead of saying x, I will now say 1 minus 5 is greater than or equal to 4 times 1 minus 3. Let's work it out real quick. 3 minus 5 is greater than or equal to 4 minus 3. And then we'll end up getting negative 2 is greater than or equal to positive 1. Does that make is this statement true? Is negative 2 greater than or equal to 1? It is not. It is a false statement. So in this case, x less than or equal to negative 2. That means any solution that is less than or equal to negative 2. Any number, it works. It's a solution. So the question is just asking, hey, what's a number greater than negative 2? In this case, a, negative 1 is the only one that works.